Hi, in this video I will teach you what is a unit vector. So let's start with the definition, which is very easy to understand. Well, when do we call a vector unit vector? A vector U is called a unit vector if its length is unit or is equal to 1. That's where the word comes. In other words, if I write it in terms of the notation for the length, that means that the length is 1. Well, just it means that when someone gives you a vector, you to check it if it is unit or not, just find its length. If it is equal to 1, it's unit. If it is not, then it's not unit. That's it. So which one is unit? Let's do this example. First vector is 1 over root 2 and negative 1 over root 2. The second one is 1, negative 1, 1. And the third one is negative 1 over root 10, 3 over root 10, and 0. Okay, so vector is given. We want to check if it is unit or not. Means what? We need to find its length. And the length of a vector means that you square each component, add them, and then find square root. Here it means what? So here's 1 squared over root 2 squared plus negative 1 squared over root 2 squared. And we know that the square of root 2 is 2, square of 1 is 1. So we have 1 over 2 plus 1 over 2. You add them, you get 1. Square root of 1 is 1. The length is 1. That means that this vector is a unit vector. How about this other one? Well, okay, we need to find its length. Here, well, square each component, add them, and then find square root. Here, square of 1 is 1, square of negative 1 is 1, square of 1 is 1 again, so this is root 3. Root 3 is not 1. That means that the vector we have here is not a unit vector. How about this last one? Okay, the length of this guy here is as we have, yes, square each component and add them and then find the square root of that. The similar computation as above shows that this is 1 over 10, this is 9 over 10, and that's 0. You add those ones, you get 10 over 10, which is 1, well, root 1 now, it's 1. So we see here that this vector is a unit vector. Well, if a vector is not vector, a unit vector, we still can find a unit vector which has the same direction. In other words, unit vectors are going to play the role of direction for all the vectors. So this is the fact we need to know. And fact for every given non-zero. This is something. The zero vector doesn't have direction, so we cannot do anything with that. So if you drop the zero vector, non-zero vector u vector v, well, there are two unit vectors that we need to learn. First is there exists a unit vector in the same direction as v. If v is not unit, or even if it is unit, doesn't matter, we can find a unit vector. How this unit vector we can find it? Well, it is that unit vector is, you first find the length of v, and then 1 over the length, this is a number, you scalar multiply by the vector itself of v. What does it mean? It means that, well, if v has three components, v1, v2, v3, you multiply 1 over length of v to each component. So it is v here, v here, v here, and that is the vector we are looking at. It is unit because when you find the length of this guy, it is going to be 1, and it has same direction as v. Well, what about if it is two-dimensional? Well, that goes the same way. So it is this, but we have only two components. Yes, so we'll stop there. How about other case? Well, we can also have a unit vector in the opposite direction. As v. Well, if you want to find an opposite direction, what you need to do is the same story goes there. So you find the length of v, you divide it, you inverse it, and then to have opposite direction, we have to multiply it by a negative sign. So in other words, the vector here is going to be minus v1 over length of v, minus v2 over length of v, and minus v3 over length of v. And the dimension 2, well, on our two vectors, it's minus 1 over v and minus v2 over length of v. Well, if a vector is non-zero, we can find a unit vector which has the same direction or opposite direction. How do we find it? This is how do we do. In dimension 2, we do this. In dimension 3, we do. But in general, it's just inverse the length of v and then multiply to v itself. That will give you a unit vector. Let me just do an example here before we leave. Example, find a unit vector, well, with the same direction as the vector that we did in example 1 here, as 1, negative 1, 1. We saw that it's not unit. Now we want to find a unit vector that's with the same direction. How about the unit vector with the opposite direction? As vector this time, let's say just 3 and negative 4. Well, okay, let's do this example. The first part is that this is our vector v. We have to find the vector u, which is unit vector and has the same direction. What should we do? We have to find first length of v and then multiply it by v. So length of v is what we need to find. We did it in the previous example. It was root 3. Now this means that I have to multiply 1 over root 3, inverse of the length, to 1 and negative 1 1, and that means that we multiply each component by 1 over root 3, and the vector we find is unit vector, which has the same direction as the vector 1 negative 1 1, and yeah, that's it. That's the unit vector in the same direction. How about the other one? This time we are looking for unit vector which has the opposite direction. So u is going to be, well, 1 over length of v times v itself. But if this has the same direction, its unit vector has the same direction, if you multiply it by negative sign, it will give you the opposite direction. So here I need to know what is the length of the vector v, which it is score each component. When you're scoring negative numbers, you have to be careful. The negative will go away, and that will give me 9 plus 16, which is 25. Root of 25 is just 5. So we'll do negative 1 over 5 times 3 and negative 4, and then this goes inside. It's negative 1 over 5 times 3, negative 1 over 5 times negative 4, which gives me negative 3 over 5, and 2 negative signs 4 over 5. Okay, so in this video what we learned was that, first of all, when we call a vector unit vector, and then we learned that every vector you give me, every non-zero vector, we can find a vector unit vector which has the same